Kontorer. Once again, thank you.
Namaste. Very excited to be here. Nice to meet you all. I shall get straight to the talk, and actually I plan to do a sort of short introduction, but already introduced me. I am an instructor, a penetration tester, and the offensive team leader in HackerU. And what I will be doing today is doing kind of the opposite of the traditional way. I come from the world of cybersecurity, and whenever there is a cybersecurity convention, there is someone that is talking about artificial intelligence and machine learning. Today I'm going to do the other way around and talk to you guys about the world of cybersecurity and the future of artificial intelligence and machine learning in this field. Now, I'm going to give you a short introduction of cybersecurity terms that I will be discussing throughout the lecture. I will guess that you know most of the artificial intelligence and the machine learning that I will be discussing about. We'll oversee some of the security risks that we have at the current moment and in the future, and how AI could be affected in those fields. I'll discuss a particularly interesting subject, which I guess some of you are interested in, which is the malicious usage of the artificial intelligence in advanced malware. But as well, not only the offensive talk will be, there will also be a discussion of the defensive implementations of AI, which is something we are more familiar with due to some reasons I will also explain. Now, I come from the world of offensive security and penetration testing. And we like to look at every attack as a sequence of events, starting from reconnaissance down to the actions on site after our target has already been compromised. Now, each step has its own unique characteristics, which perform the action to help us move further along. For example, the delivery stage at which we already identify the target and now send our malicious payload in order to perform the exploitation. Now, when discussing AI, we can actually implement it in all stages. But in some stages, it will have a much greater effect and empower the actions beyond what we think. Now, we have artificial intelligence in both the offensive and defensive sides of the equation. Now, as many of you might have heard, the most of talk goes about the AI in the defensive strategies. The reason is not because there is nothing to implement in the offensive side, but because it is much more creative and requires some more understanding of how to correctly do it. Because what we ran into is a major question. Like, we talk about AI, we talk about training a certain model to understand, recognize, to think. What can we feed such a model in order to get what output? Can we feed it a database of attacks and expect it to generate a new type of attack? When we talk about offensive, when we talk about defensive, it's pretty clear. We can feed it a database of attacks and teach it to identify them. But it also varies depending on the types of attacks that we feed it. We also need to consider the types of learning we are familiar with. The three major types are supervised learning, unsupervised learning, and reinforcement learning. Where both supervised and unsupervised are great for understanding a certain component, for classification, but this is not what we do in cybersecurity. In cybersecurity, we don't identify a target as vulnerable. We test if it is vulnerable, and it is a single condition. Whether there is an exposed port to the outside world, whether there is a service which was misconfigured or not updated in time. There is no implementation of real thought there. Reinforcement learning, on the other hand, does take us more into that direction where I can take an attack, learn how it happened, and try to mimic it. And if I manage to perform a set of actions, then I have successfully implemented the attack. But again, when we look at the world of cybersecurity, each attack is different. Almost no attack is executed in the same way. So there are really a lot to learn. So as far as we go into the offensive risks, we need to consider that AI is not automation. And this is what mostly happens and people discuss in the cyber community. How to take something and automate it. But it's not quite the best practice, because if we look at an attack like a brute force attack, when you try to guess a password or credentials for some service or an account, we can't teach artificial intelligence to perform such an attack. But should we really? Because it's a simple trial and error. We try and we try and we try, and eventually we'll succeed, but there is nothing really smart, there is nothing really to think about it. It's plain automation. AI has far better usage we can implement to address certain risks. We used AI. One of the primary things that we did was to use computer vision to identify certain components within a picture. For example, we can take a picture of a cat and identify that it is actually a cat. We can identify components from within the picture, such as what is the ear, what is the eye. For this, we use neural networks, multi-layered deep neural networks, which take a picture, some feed, and pass it through the different neurons, identifying the components, eventually telling me, yes, this is a picture of a cat, or yes, this is a picture of a dog. We can take it a bit further, and at this point you might be asking yourselves, well, how do classification helps me in order to execute an attack? What type of attack are we talking here about? Well, in order to explain this, we actually need to take a more advanced step and start combining more than one neural network. If you're familiar with GANs, GANs are generative adversarial networks. We take two networks, two neurological networks, and let them fight against each other, not actually fight. We take the first network and train it to identify the same components as I demonstrated before. We take a cat and teach it to identify a cat. The neural network learns and eventually is able to tell me whether the picture is a real picture, a fake picture, a cat, a dog, or anything else. At the same time, I can take a second network and instead of feeding it a database of sets I do know what they are, I feed it random noise. I feed it random noise and I teach it to generate new things. At first, it will fail, but soon enough, it will learn how to take this random noise and sort it into something that I want, eventually generating a picture of something that looks like a cat. This data will be fed once again to the original, the first network, which will be able to identify whether the second network successfully created the picture that I wanted. And so after a while of training, I will have a network that is capable of creating new data, new, very convincing data. Now, here I was talking about a picture of a cat, but imagine we are talking about fingerprints. A few studies in the New York State University and other places as well tested this theory with artificial fingerprints. They used a few databases of fingerprints and taught a computer to identify what is actually a fingerprint. They took another network, fed it random noise, and taught it how to generate fingerprints. At the end of the experiment, which took a few weeks, they managed to replicate fingerprints which were identified with 22% of the population with a 99% match, meaning the fingerprints were so real they could be easily mistaken for real ones. Now take this thing and combine it with many vulnerabilities we discover in sensors, facial recognition, fingerprint scanners, when we had sensors we could trick by showing a picture of face. But here, imagine feeding it real data generated by an artificial network that has the exact same match. And this experiment is not very hard to replicate, and it's just a few lines of code and a lot of training. This type of vector attack is actually a new vector of social engineering attacks when we trick not only people but also sensors now and can gain access into unauthorized places. This is a sort of hacking that takes place in the real world and not only in computers, and also something to be aware about. Now we have two more types of attack vectors for which we could implement machine learning and artificial intelligence. One of which is deep hack. Deep hack is actually an example, something that was presented by Bishop Fox in the DEF CON 25th edition, where he took an artificial intelligence network and taught it how to hack without giving it a single line of code regarding to hacking or what attack to execute. They managed to teach the network to perform attacks and perform malicious SQL queries on databases. Now, there is still a long way to go here, but with POCs already released, it's just about waiting for the artificial intelligence to create its own tools. But what I would rather focus about is the intelligent malware, because there is much more depth in which we can go in this specific area. Now, what is an intelligent malware? What is malicious intelligence? If we look at the evolution of malware, we see that around the 80s, we started obfuscation, mutating the payload. The malware, once arriving on the computer, started to change. It mutated the code so during execution it will be a little bit harder to detect it. In the 90s, we added a layer of encryption. We packed the malware inside a packer, which code should not be identified by any endpoint protection or antivirus software. Only once it was executed, the actual code was revealed and the actions was done. In the 2000s, we started evading debug technologies and virtualization technologies, all in the purpose of making our malware as covert as we can and not be identified or make it even hard to be researched by the different malware researchers that could analyze the malware. In 2010, we started giving it another twist. We made the malware target certain organizations, certain people. We made it semi-intelligent. The malware would not execute just on any computer. It would search for a specific target on which it would perform the actions. Such an occasion was when Stuxnet was discovered. Stuxnet is a great example of such targeted malware that was discovered around the year 2010. For those of you who are not familiar with it, Stuxnet was a malware that actually is suspected to spread out since 2005. Now we're talking about 5 years in which the malware managed to spread undetected until it reached the specified target. Now the specified target was nuclear power plants and SCADA networks in Iran. Only when it reached this infrastructure, it executed the code and caused the turbines to malfunction and caused severe damage. Now, this malware was a semi-intelligent malware that started the attack somewhere in the world. We don't know who is responsible for it. We only can suspect. It started to spread, and each target it managed to gain access to, it checked whether it contained the systems that were targeted or did not. Once it did find, finally, the systems on which the SCADA networks, the SCADA infrastructure reside, they executed the code. Now, let's think a bit. We were able to make a malware check a simple condition. What if we take artificial intelligence and manage to embed it within the code itself? We could try to search for more critical identifiers. Instead of getting a false positive and maybe I reached another SCADA network, we could search for things like software environments. We could try to identify geolocations. We could try to identify visual and audio signals from sensors. Our phones have cameras, they have mics. Our computers, the same. If we have an intelligent component within our code, it could address those sensors, get the data from them, and identify a target based on its biometrics, based on its voice, look, scan the face, and if it detects, then it will execute, as well as user activity, of course. Each business has its own way of work, and it could also be trained to identify certain actions and activate itself during certain hours regarding on clock actually defined, but by the type of work. For example, execute the malicious code when it is the busiest hour at work, when there is the most network traffic. It could learn those things. One second before the video plays, such an example for intelligent malware was developed by IBM under the label DeepLocker. And this is how they introduced it.
Cybercriminals are studying up on artificial intelligence to use it for their advantage and weaponize it. At IBM Research, we developed DeepLocker to demonstrate how existing AI technologies can be combined with malware techniques already being seen in the wild to create a new breed of attacks. DeepLocker is a new class of highly targeted and evasive malware. It's using AI to hide its malicious nature in popular applications until it reaches a specific target. It's identifying its target by means of AI models through indicators such as facial recognition, voice recognition, or geolocation. What is unique about DeepLocker is that the use of AI makes it nearly impossible for security experts to detect the target ahead of time. The security community needs to prepare to face new levels of attacks, AI-powered attacks. We can't simply wait for these attacks to show up in the wild before we ramp up our defenses. IBM is leading the way to navigate the threats that AI-powered attacks could bring to organizations and help them to stay ahead of the cybercriminals.
Now, this is the reason I found it fascinating, because this is actually one of the best implementations we could take for intelligence and put them in the world of cybersecurity. Now, cybersecurity risks are happening every day, and such risks are extremely frightening in a way, because those will be the risks which we find harder to identify. It not only stops with the targeted search. Let's take a step back to the encryption part. We have a neural network. We teach it to identify a target. If we look at the code, we can extract the components it identified and the amount of accuracy it detected from identifying our target. We can feed this data into another network simply to get a more concrete answer, more fixated numbers, and use these numbers for encryption. Use these numbers as a key. This key would be unique to our target, and this key will not be hard-coded. This key will appear nowhere in the code because it is generated only when our artificial intelligence identifies our target. So we have an encrypted malware which is encrypted using AI. There is no hard-coded code. There is no hard-coded key. There is only intelligence. We have a malware that we don't know who it is targeting, because there is nothing that tells me that it is looking for SCADA, that is looking to identify that it is in a certain country. We have nothing like this. We don't know what is it looking for. We don't know if it's looking for facial scans. We don't know if it's looking for voice samples. We don't know what location it is looking for. And we don't know what it does. We don't know what code will be executed because the entire thing is encrypted. With a key, I do not have. This is an extreme threat that we do need to think how we can prepare for. Now, it's not also bad. There are ways to protect against those things. There is possibility to monitor for artificial intelligence usage on computers that were not intended to run such a component. We can block access to sensors, and this is kind of a bandage we can put, like, put a bandage on the camera. We do that. We could try to use deceptive attributes in our environment, such as fake locations, fake times, but also not very efficient. As far as the proactive approach, we can try to brute force the attributes, try to feed it pictures, try to feed it voice samples. We could try to investigate the code and understand what is actually the AI looking for. But as you are aware, this would require us a tremendous amount of resources, time, and with the emerging threat, we might not have this time. There might be a problem for which we need to prepare before we reach it. Now, when looking at AI, when looking at cybersecurity, actually, the way it works is that there's usually an attack and then a defense developed against this attack. For our luck, in most cases, the initial attack is in most cases developed by white hat hackers, researchers that perform the attacks for the greater good in order to understand them, study them, and develop appropriate defenses. Only once in a while we discover an attack that is actually out there in the wild, but those happen as well. One thing we can hope for, and we actually might achieve this in the near future, is that we will not only harness AI for offensive direction, but we will use it to identify threats before they happen, and we'll have the possibility to prepare defenses even before we have the attack with smart predictions we can make. Now, there are already products which use artificial intelligence in order to set up a new line of defense. It's a bit different from predicting, although it is a component, and there are three major aspects which we do identify at the moment. One of the attacks is phishing campaigns. Another is malware detection, not an intelligent malware yet, but regular malware we do encounter and hear about day by day. And another thing is an intelligent SIM, which I will discuss after the first term. Why did we use artificial intelligence for phishing mails? What are phishing campaigns? Phishing campaigns, for those of you who are not familiar with those, are all those, hello, my name is something, and I am the attorney of a famous Nigerian prince who died and wants to contribute you $1 bazillion, just because you are somebody who can help. It sounds tempting, but it is likely fake. I wish some Nigerian prince would inherit me all this money. Now, those phishing campaigns are becoming more advanced, not advanced technologically, but more persuasive. People are getting better at it. The messages sound more convincing. The links look more realistic, but the general structure remains the same. It is a very persuasive mail with a link to a suspicious site which forces you to either download a file or, on the contrary, submit some credentials. AI is best suited to identify those things. It could identify the structure, and even something that will seem somehow convincing for a person could be easily identified by the predefined components. And so we could add a line of defense that even though a human being can be tricked, if we have some sort of a solution which sits at our mail server and scans through our mail and detects and analyzes those things, can prevent even the most persuasive phishing campaigns. As for malware, I like to refer to it as the duck test, and I was missing animals besides the cat, so we have a duck. The duck test is very simple. If it quacks like a duck, swims like a duck, and walks like a duck, it is likely a duck. And same goes with malware. If it looks like malware, acts like malware, and spreads like malware, it is likely a malware. We have been experiencing malware attacks for the last decades, and even different types of malware before that. And we learned so much about them, and although they're somewhat different from one another, and every ransomware works in a bit of a different way, and the ransomware is not exactly a Trojan, we still have enough data to be able to build a model and identify what a malware is, what is a ransomware, what is a scareware, what is a Trojan, and what is a worm. Many antivirus and endpoint protection software have those databases and can use the knowledge they've gathered in previous years and implement AI in order to identify those at near real time. And this is already being done, and most of the endpoint software providers, most of the antivirus programs do implement AI in more simple or more advanced way in order to identify malicious activity before or just in time when it is executed. And this is something that will identify a malware even if its signature or its identifier was not yet identified completely, released or discovered by a researcher who went and dug through the code to understand what it does. Because nowadays, most malware are identified by some sort of a string or a piece of code or a sequence of bytes which is unique to that family. And what HackerU do? Why did I say family? Because malwares are not usually standalone. There is a family of different types which bear the same core and simply changed a few attributes. Instead of searching for John, it searches for Jonathan. And these tricks are used to bypass traditional endpoint protection. But advanced endpoint protection with the usage of AI can identify those simply by its behavior. Last thing, which is also being done now more and more, and I expect to see it more in the future, is the intelligent SOC, intelligent SIEM, intelligent EDR, endpoint detection and response. Because when we're dealing with security, all the major companies are deploying SOC operators and SOC analysts which monitor everything that is happening. They have a lot of different security components, firewalls, DLPs, endpoint protection, which know to generate alert once they find something suspicious. But it is a single alert in a huge sea of data. And this alert might as well be a false positive. We don't know if it was triggered by mistake or is it really something suspicious. Because of that, we have SOC analysts, which inspect the data, try to perform correlations using software like a SIEM, and trying to identify whether a set of alerts we received was actually related to an attack. Now, let me tell you something about humans. We are slow. Computers are much faster than us. A computer who is able to identify and correlate those individual trigger points, those individual red flags, will be able to perform some reconnaissance on the data it received, will be able to perform near real-time analysis of the alerts and notify us whether an attack is really happening. Usually it takes some time for a malware, for a threat to be discovered within the organization. It's a strange number, but when you think about how much time it takes before a threat is discovered, after it has been inside an organization, the average time is about 6 months. 6 months for the threat to be inside the system until it is detected. With usage of machine learning and artificial intelligence, which is able to take this process, and this process it's not enough to do automation here. Because if you have a bunch of false positives and you automate false positives, you still get false positives. But if you take an intelligent component and teach it how to identify a false positive from a true positive, you have a system that can actually respond. Before I finish up, I do want to go and discuss a few of the solutions we already have implemented in the world. I started with talking about antivirus and endpoint detection. One example, and one of the major examples, is CrowdStrike. CrowdStrike is an endpoint solution which resides in the cloud also. We're technological, we're moving everything to the cloud. The main mind sits in the cloud, collects data with agents distributed on the stations within the organization, which samples potentially malicious software, send it to the cloud where it is being analyzed. Now, with thousands and possibly millions of companies which send data to a single mind which is able to analyze it and learn new attacks, we will be able to identify new threats before databases get updated, because it is happening in live, and the data set which is used for training is constantly growing. This is from the perspective of the endpoint protection. But we have some component in every organization that is by far more distributed: firewalls. Because, well, who doesn't have a firewall? Firewall can also be made intelligent. Because when we inspect firewall rules, we do allow traffic or we don't allow traffic. For example, we could say that we want to prevent access on a certain port for a certain service while allowing a different service. It worked well until cybersecurity researchers and various hackers decided, all right, but what if I use a legitimate protocol? For example, there is DNS. DNS is dynamic name services, used to translate those site addresses, which we're all familiar with, to the actual IP addresses of computers on which our servers reside. Now, I know almost no company that will block DNS traffic, because within the organization, outside the organization, DNS is used. So hackers decided to do the following and simply hide their malicious traffic, their connection to the command and control server, within a DNS tunnel. A DNS query eventually contains a piece of information which is looking for the name of the site. So instead of the name of the site, they hid malicious data inside there. And the regular firewall will not be able to detect it because the traffic is legitimate. It's DNS traffic. Nobody told it to block it. However, using artificial intelligence and integrating an intelligent component within the firewall, it could identify the target and say, I know that it is DNS, but it's too large to be a DNS query. There are too many of those. There is a particular domain which I find suspicious due to the nature of it and the data set I've been trained with. And we start to see more and more of those appear in the market, and I do trust that we will see much of those in the near future. Another solution might be an integration of both. Checkpoint, a well-known security company, took the same idea and also integrated identification of malware and malicious traffic into their products. And when we think about it, Using this model, we could actually identify one of our greatest threats, 0 days. What are 0 days? 0 days are attacks that we have not discovered, are attacks where we don't know who attacking, what attacking. We don't know what vulnerability it uses, but it is malicious, and we're able to identify malicious because we are intelligent. We use machine learning to train enough samples to identify malicious activity even though we did not know this sample. And this is our future, where we will be able to discover new attacks before they occur. We will have a line of defense all set up and ready way before the attack actually takes place. We don't need to encounter this type of specific malicious activity. We know what malicious activity looks like. We know how it will behave, and we're able to identify it. Aside from the protective, we also have automation. It's not automation, it's intelligence that can be used in order to protect the organization in real time. Darktrace is an example of such a solution which implemented artificial intelligence inside an EDR, endpoint detection and response, where it analyzes the data gathered, analyzes the alerts, analyzes the traffic, the samples, and everything, and is able to determine whether we're talking about malicious activity way faster than a normal human being might have done it. Now to summarize, what are we actually expecting? All the examples I gave during the presentation are not from 5 years ago, not even 4. They're from the last 2 years. Research presented in the last 2 or 1 year. We did not imagine we'll have such malware. We did not imagine we'll have such defenses. But we're also a bit struggling to imagine what we'll have, because the impact artificial intelligence could have on cybersecurity is so much greater. Because consider taking the mind of a human, which is capable of doing amazing things, and bringing it up to the speed of a computer. Dealing with threats will become much more advanced than it is now. We'll encounter more advanced threats, such as the intelligent malware. But on the other hand, we will be able to identify those threats much faster and possibly prevent them before they actually take place. There will be a race, whether we utilize this fast enough for defense or whether somebody gets ahead of us and uses such a good thing for such a bad reason. At the moment, we have not yet discovered such implementations of malicious activity that implements AI in the wild. Only at researchers such as IBM's or the New York State University, where they created the fingerprints. But as we suspect, there already might be, and we will see such things in the near future. Cybersecurity is a field that is advancing at tremendous speed, with a curve that is much more advanced than most other technologies which we saw that developed over time. There will be a need for more cybersecurity researchers and more artificial intelligence and data analyst personnel in the cybersecurity world. As I started my talk, in every cybersecurity convention, there is somebody who talks about IoT, cloud, and of course, artificial intelligence and machine learning, and how it will affect our world of cybersecurity. This is it. And now, if you have any questions, I will gladly answer them. Yes.
Thank you, Leon. Fantastic talk, very insightful.
Thank you.
My name is Ranga. I just want to draw a parallel for the offensive cybersecurity that you said.
Yeah.
Where you said you can train a system on existing attacks, and it can come up with a new attack, or
Yeah.
you can craft a new attack. Now,
It
2
will-
days back, OpenAI released a news that, using reinforcement learning, they had agents playing a game of hide and seek. And just as the agents that were hiding developed new capabilities, like they could use tools to hide themselves better, which they were not explicitly trained on, the same way the offense, which was trying to find the agents, also developed tool use. They started using a ramp so that they could get into the, sort of the building that the agents were hiding in. So this was sort of unexpected because the agents was not specifically trained to do this. So is that a fair parallel to what you're saying, where you're training on known attacks, but then you discover something that was never known?
It is a possibility, although most attacks already have a predefined scheme. We have the suspicion that there might be a new attack vectors which we did not think about. There will likely not be too many of those, but which is likely is for new advanced and more logical tools that will perform the attack in a much more efficient way that we currently do. Because an artificially intelligent system might find a way to do a certain attack we've already been doing for years in a more sophisticated or a more simple, both combined, way in which we simply have not thought of that idea. And during its understanding of the attacks, it will find a way to do this more efficiently.
All right, to your left.
Yeah.
Leon, that
When
was
we're talking
great.
about
Wait,
I'm sorry, I'll just, thanks. When we're talking about the future of cybersecurity, right? And in the current geopolitical climate where nations have conflict, right? You have Iran versus Saudi Arabia, India and Pakistan, Russia and Ukraine, USA and China. What's your opinion on the possibility of something like a nuclear weapon in terms of, malware, and a possible way to, have something like a United Nations, which sits not just at an organization level or a country level, but across countries, which can act as like a peacekeeping force for this?
Well, we do encounter things related to this field. It's not a secret that there are cyber attacks going between countries, whether it is by private organizations or governmental organizations. And the example which I talked about, Stuxnet, was a malware that was targeting nuclear power plants. It is a possibility, but we do need to consider that there is a fair amount of resources dedicated in order to protecting those so dangerous risks.
Leon?
Yeah,
That was great talk.
thank you.
From the technological viewpoint, there has been quite great developments in quantum computing and quantum attacks that were able to crack the keys that would take, let's say, for a supercomputer maybe 10, 12 years. The quantum computers are able to crack that just in 8 or 14 hours, right? And there has been also some developments in quantum AI, that would provide even faster, mechanism or faster ways of detecting patterns, analyzing patterns. So how do you see that these two would go, in security domain?
There is some more research to do in that field and some more measurements to do, because it might seem simple on paper, but if, for example, we take a simple brute force attack, before we jump to quantum computing, look at a simple brute force attack. If we have a 4-digit password, it will only take us a few minutes to crack it. If we have an 8-digit password, it will take a few months to crack it. With only adding 4 digits, we increased it from minutes to months. Now, we did advance and started using advanced computing, graphical cards, which are capable to do more testing in less time. We brought it down to weeks, not months. But then we take and we increase the password to 16 characters. And now it's not months, it's years. Now, when we're talking about brute forcing a neural network, there are much more layers, there are much more attributes than just 16 characters. And I'm talking about the most simple neural with let's say, 10 hidden layers, not more. Now, quantum computing will increase the speeds on which we can try to perform this anti-attack. But the statistics which show how the difficulty to crack something increases with the amount of data to crack, it's not a single line. It's a steep curve which goes way up, way too fast.
Hi, Alon, I have a question here.
Yeah.
Excellent talk. Do you see a flip side of using artificial intelligence, because it detects threats and everything based on what existing threats are, the usual patterns and what is there in the wild, but maybe something that's not so automated and not a part of artificial intelligence can be creative enough to understand that there could be other sorts of attacks?
No, this is the point of automation. Automation repeats the same task over and over again. It does not learn. This is why we need artificial intelligence, to learn and identify new things which were not identified before. Now, my time is up, and I just want to summarize with one thing. There is a great need for cybersecurity, and there is a great need for artificial intelligence in cybersecurity. And what we see for the future is a huge increase in demand for artificial intelligence and cybersecurity worldwide, not only in countries like India or countries like the United States, but really worldwide, where experts will simply start to spread out, because faster and faster people are understanding the importance of it, and the demand grows, leaving a gap open for people to fill it. Thank you very much.